Then, so let me go back here for the sake of recording. We have the binomial probability distribution, which will focus, which will be our focus today. And from the word by here, by means two. So in this experiment, we are going to have two outcomes, whereby one of the outcome, which is actually the favorable, we normally call it the success, and the other is normally known as the failure. The success is normally denoted by P, and the failure is normally denoted by Q. And from what we know, the probability of an event happening, that is the probability of a successful event, plus the probability of the same event not happening, which is now the failure. If you add the two probabilities, they should add up to 1. Therefore, if we have said that success is normally denoted by P and failure is normally denoted by Q, if you add P plus Q, then it should be equal to 1. And from this equation, we can have this, that P is equals to 1 minus Q when you take Q to the other side, and the Q is 1 minus P when you take P to the other side. That is actually the starting point. After having noted that, I was at this point whereby I was giving an example. You can give 10 students, you have 10 students, and you give them maybe a cat. The probability of passing, the probability of a student passing the exam is given by maybe the probability of a student passing an exam. I don't know why my internet looks unstable, but the probability of passing is maybe 1 over 6. If they were 10, each of them has got a probability of 1 over 6. Therefore, it simply means that the probability of a failure being recorded there would be equal to 1 minus 1 over 6, which will be actually what? Which will be 1 minus 1 over 6. Which will be 5 over 6. Because 1, if we are minusing 1 over 6, this 1 is the same as 6 over 6 minus 1 over 6, which is the same as 5 over 6. So this is our Q, this is our P. The number of times, in this case, because we have got 10 students who are going to sit for the exam, the 10 are normally denoted by N. N is the number of times the experiment will be repeated. Number of times the experiment will be repeated. In this case, it is 10. Now you can be asked this question. What is the probability that 6 students will pass that exam out of these 10? The 6 students, the number of successes in this case is normally denoted by X. This is actually the number of success. So I want to repeat here before I go now to the formula. Passing is normally denoted by P, and failure is normally denoted by Q. In this case, you will only be given the probability of passing or probability of failing, and from that equation that we have discussed, you can be able to get the probability of the other. Like, for example, if you are given the probability of passing, the probability of failing will be 1 minus that probability of passing you get is this. Then the number of times that experiment is going to be repeated, because this exam is going to be given to the 10 students, then 10 students is going to represent as the N. And then if the question is talking about the number of successes, in this case, we are told the probability that 6 students will pass that particular exam. Therefore, X is going to be the number of success. So in short, N would be equal to 10, and X will be equal to 6, because the question is telling us that 6 students to pass. Having noted that, now we can go to the formula of the binomial distribution. The formula for calculating the probability. Probability that X events are going to be successful is normally given by N factorial over X factorial into N minus X into bracket factorial. Then this one you multiply by Q, you multiply by not Q but P power X times Q power n minus x. So if we can go to our question, remember our P was the probability of passing, which was 1/6. Our Q was the probability of failing, which was 5/6. Our N was the number of times the experiment is repeated, which is 10. And our X, it is the number of successes that we are interested, which is actually 6. We can come and substitute these values here, and we will see the probability that six students are going to pass, because our X is 6, is going to be given by 10 factorial over x.
Hold.
Hey, you guys. Is it just my screen?
Kuna shida.
Oh.
Net yake iko na shida.
Oh.
Hello? Hello?
Hello?
Hello?
Okay, let us
Please start again from the formula.
Okay.
We lost you almost the whole time.
Okay, I won't mind to
Just
repeat.
start again from the formula, please.
Okay. The formula, it is given by n factorial. Remember, our n is the number of times the experiment is going to be repeated, over x factorial into bracket n minus x factorial. Then you multiply by p power x. Remember, our x is here, times q power n minus x. If we can substitute these values now in this particular formula, you'll find that the probability that 6 out of the 10 events are going to be successful is going to be equal to n factorial, which is the same as 10 factorial, over x factorial, which is 6 factorial, times 10 minus 6, which is the same as n minus x. And then you multiply by p power x. P power x is the same as 1/6 power 6 times q. Remember, the probability of the failing is 5/6. So it's going to be 5/6 power n minus x, which is the same as 10 minus 6. Therefore, this one will be equal to what? I want you now to take your calculator. This one can be done very fast using the calculator. If you have your calculator with you, you can be able to get the 10 factorial. There is a button just below the shift button. Just below the shift button, there is a button that is there. And it is actually on top of it, there is x factorial. There is that sign of x factorial. I hope you can be able to see that. So for you to get the 10 factorial, you just press 10, shift, and then you press that button that is adjacent to x factorial. And then you can press is equals to what? What are you getting? I want you to participate here. We are looking for the 10 factorial. You press 10, then shift. There is a button that is here, and then on top of it, there is x factorial. So you shift, you put 10, shift, and then you press this button. What is the figure that you are getting?
3 million.
Exactly.
628,000 and 8,000. 628.
800.
8,000.
8,000 or 800?
800. Yeah, 800. Sorry.
Exactly.
800.
Yes. And note, when we are talking about 10 factorial, it is the same as 10 times 9 times 8 times 7 times 6 all the way up to times 1. So that is what we mean by 10 factorial. It is 10 times 9 times 8 times 7 times 6 all the way up to times 1. So you get that is the 10 factorial. Now, what about the 6 factorial? If you do 6, then you shift, then that button for factorial.
720.
Exactly, 720. And then this one you multiply by 10 minus 6. There's a factorial here. 10 minus 6 is 4. So you do 4 factorial. 4 shift, then that factorial. You get it is what?
34.
24.
24.
Can you work out that first of all?
24.
Yes. Can you work out this?
To 10.
Get this answer is coming to 210. Thank you. This 210 now you multiply by p power x. Remember our p is 1 over 6. So can you do 1 over 6 power 6? 1 over 6 power 6. 1 over 6. What are you getting?
1 over
1 over
46,000.
46,000.
656.
656. Then you multiply by 5 over 6 power 4. Remember 10 minus 6 is the same as 4. So you do 5 over 6 times all power 4. 5 over 6 power 4.
5 over 1,296.
Let me repeat this. You have said 1 over?
5 over 1,296.
5 over, can you repeat again, please?
5 over 1,296.
5 over 1,296. I want you now to work out this. 210 times 1 times 5. Remember, this is the same as 5. 210 times 1 times 5. What are you getting?
1050.
1050.
1050. What about 46? 46, 656 times 1296. 46, 656 times 1296.
60 million.
It's going to
60
be,
million.
just a minute, let me multiply 46, 656 times 60 millions, 466,
166,000.
100 and,
176.
can you divide that now?
Yeah.
Can you divide that? 1050 divided by answer. you will find is actually going to be
0.00000.
actually it's going to be 4 zeros, 0, 0, 0, 0,
174.
174. You find that that is going to be the probability, which is very, very small probability, very slim probability. So that is actually a question that I just had it from my mind. I want us now to go to what we have in our notes and in our revision questions. There is a question that is on your notes about suppose that it reads like this. I know you will get it, but let me give a summary of that question. You are told that suppose that 80% of adults with allergies report symptomatic relief with a specific medication. 80% they report symptomatic when they take a certain medication. If the medication is given to 10 patients with allergies, what is the probability that is going to be effective in exactly 7? It is going to be effective in 7. One thing you'll be able to realize this, 80% is the probability of success that those patients are going to register relief. And note, therefore, P is equals to 80%, which is the same as 0.8. Therefore, Q will be equal to 1 minus 0.8, which is the same as 0.2. It simply means that there is a probability of 0.2 that these patients, when they take that medication, they are not going to have any relief. Then this is our Q. The number of patients the medication is going to be administered to is going to be our N. And then X is going to be 7. So you are asked, what is the probability that if this medication is administered to these 10, only 7 are going to register relief? So you should come here and you say the probability that 7 are going to register relief is going to be given by n factorial, which is 10 factorial, over 7 factorial, which is x factorial, into 10 minus 7 factorial times p power x, which is the same as 0.8 power x times x actually is 7. Let us not put x, times 0.2 power 10 minus x, 10 minus 7, which is actually 3. I want you to try that. 10 factorial over 7 factorial into 10 minus 3 factorial, and then we multiply that. Can you be getting the answer? Already we had an answer for 10 factorial somewhere.
$3,628,800.
Just a minute, just a minute. So you said it's going to be, what is the answer for 10 factorial?
3,628,800,000.
800. Then 7 factorial, what do you get?
5,040.
5040. Then you times, this is the same as 3 factorial, 10 minus 7, and then you put factorial. 3 factorial is the same as
6.
6.
Yeah.
Then this one we multiply by, what is the same? What is the answer for 0.8 power 7?
0.8.
0.8.
0.2097.
0.0297 times.
2097.
Just a minute then.
Okay.
0.20.
Yeah, 97.
What about 0.2? Remember, this is the same as power 3. 0.2 power 3.
0.008.
0.008. Can you work out this? I want you to work out this part here. Get for me, first of all, the answer for 50, 40 times 6. 50, 40 times 6, what do you get?
30,240.
30,240, yeah? Okay, then divide this. Divide this. Divide this.
120.
Sorry?
120.
Yes, 120. Then you multiply by 0.2097 times 0.008.
Zero point two.
0.2013.
That is the probability, and that is the answer. The good thing with a question that has got a formula, it is just a matter of following the formula. I want us now to go to the past examination questions that you have, and we also do 1 or 2 so that you can be able to understand the concept better. Lukale, are you ready?
Yes.
Give us the first one on binomial.
A six-sided die
Yes.
is rolled 12 times. What is the probability of getting face labeled 4 5 times?
Okay. It is rolled 12 times. If it is
Yes.
rolled 12 times, then our n is going to be 12. What is the probability of getting face labeled?
Face labeled 4 5 times.
So actually there our x is 5. Remember, what is a die? A die is actually a cube. It is a cube that has got 6 sides. It is something like that. So each face is normally numbered. So you have, maybe this is number 1, number 2, this is number 3, number 4, number 5, number 6. They are actually 6. You will find that the probability of any face appearing on top is normally 1 over the total number of faces, which is 6. So the probability that number 4 is going to show up, or number 3, or any number, is actually 1 over 6, because each face is having only one side, and then there are a total of 6 faces. So the P here is going to be 1 over 6. The probability that 4 is going to show up is 1 over 6. Then the probability of Q is going to be the other one now, which is 1 minus 1 over 6, which is going to be 5 over 6. That is actually what you need to understand, that a die has got 6, and any face has got a chance of 1 over 6 of appearing on top. That is now the chances of success, and the chances that any other face apart from 4 is going to show up is going to be, because there are remaining 5 over the total, which is 6. After summarizing this, now you can go to your formula. So the probability that we are going to find to have face number 4 showing 5 times is going to be n factorial, which is 12 factorial, over x factorial, which is 5 factorial, into 12 minus 5 factorial. Then you multiply by p, which is the same as 1 over 6 power x power 5, times 5 over 6, which is q, power n minus x, 12 minus 5. And you are going to find it the same as 12 minus 5 is the same as 7. So can you work out that, and then you give me the answer? Work out that. Start by working with the 12 factorial, then you do all that part. Anybody who has finished doing it? Anybody with an answer? Okay, maybe somebody is doubting.
0 point
Okay, 0 point.
0 0 0 4 0 1 1 8
40.
1 8.
18. Anybody with a different
Yeah.
answer? Just say it, don't worry. If you have a different answer from this, just say it.
0.50 182.
182.
Yes.
Anybody else with a different answer? Okay, if we have got more than one answer, then it will require us to do it so that we can confirm which answer among these, or if there is any other answer. What is 12 factorial? If you do 12 factorial, what do you get? Uh-huh.
479 million.
Just a minute. Come again. Come again, Kim.
479 million. 479 million.
Yes.
1,600. And 1,600. 479 million, 1,600.
Can you say digit by digit of 479?
00, not 1.
Okay. Just a minute then.
479 00.
Okay, I'm there. 00
1600.
Okay, yeah. And then we divide by. What about the 5 factorial? 5 factorial here. What is the answer?
120.
120.
Times 12 minus 5 is 7. What is 7 factorial?
50 40.
50 40. Then you will multiply by, what is 1 over 6 times 5, or power 5, sorry, not times 5. 1 over 6 power 5. Is the same as 1 over?
7776.
7776. 1 over. Then we multiply
Yes.
by, what about 5 over 6 power 7?
It's 5 over
5 over
279
279
936.
936. Let us work out this part here up to here. I will start by getting the denominator, which is 120 times 50 40. I have it as 604 800. Then I do 479 001 600 divide by answer, which gives me 792. Did you get something like that?
Yeah.
Times 1 over 777 6 times 5 over 279 936
936
is equals to So the whole answer I'm getting is actually 0 point. There is supposed to be 5 zeros because it's actually power something -6. So it's supposed to be 1, 2, 3, 4, 5, 1, 8. So it is a probability of that magnitude. 1, 8, actually it can be 2. So it was supposed to be 5 zeros here. So that is how we normally do it. Let us go to the second question. The second question.
A multiple choice test contains 20 questions.
Okay, automatically then n is equals to 20.
With answer choices A, B, C, and D.
A, B.
Only one answer choice is correct.
Okay, there is 4 choices, and one of these is going to be correct.
Find the probability that the student will answer exactly 6 questions correctly.
Yes.
If he makes random guess on all 20 questions.
Okay, I want to go back here. We have got 4 choices. Because this particular student is making a random choice, the probability of picking a right answer out of this is going to be 1 out of the 4 choices. The probability of giving the right answer from the 4 is actually 1 out of the 4. And this is going to be our P. That is going to be our P. Then if P is equals to 1 over 4, Q will be equal to 1 minus 1 over 4, which will be the same as 3 over 4. What else don't we have here? What about the value of X? Can you repeat again?
Find the probability that the student will answer exactly 6 questions correctly.
Exactly. Therefore, X is going to be 6.
If he makes random guess on all 20 questions.
On all 20. The total questions are 20, but we are interested in 6. The solution should be n factorial, which is actually 20 factorial, over x factorial, which is 6 factorial, into 20 minus 6 into bracket factorial. Then we multiply by a quarter power x, which is the same as 0.25 power x. X is 6 times 3/4 is the same as 0.75 power n minus 6, which is going to be 20 minus 6, which is actually 14. Go ahead and work out that. Anybody who could have finished? If we can start with the final answer, if you have the final answer. Yes, anybody with an answer? Or you are not yet? Okay, we can do it together. What did you get as an answer for 20 factorial? It's actually a very big number. Eh? So what we can do is this. Let us work out this part once. If you have a calculator, we can do it together. Let us do this. We say 20 factorial divide by, and then we put bracket. We put bracket, divide by into bracket, 6 factorial for this part here, times 20 minus 6 is 14 times 14 factorial. Then you cross the bracket and you say is equals to what?
$38,760.
Yes, you get it is that 8,760. Instead of doing all this calculation, you can do that. Then you multiply by, now you can get 0.25 times power 6, 0.25 power 6, which is actually the same as what? Or let me do that question once, but you are going to get, this one is going to give you 0. You put 3 zeros, 1, 2, 3, then 2, 4, 4. I hope you are getting something like that. And then you multiply by 0.75 power raised to power 14, which is the same as 0.0178. Now you can multiply the whole of that. You can multiply the whole of that with those figures, so that you can get actually the final answer. Times what are you getting? If I do the whole thing, I'm getting 0.1686. But I want you to do it yourself. Do this. Let us feed these figures in the calculator directly the way they are. We know this part we have calculated, it is that 8760. So you can place in your calculator that 8760. Then we multiply here times into bracket. We put these figures in the calculator, 0.25 power 6. Then you cross the bracket times this figure. You open the bracket there and you put 0.75 power 14. Then you close the bracket and then you put is equals to. It gives you the answer direct instead of feeding all these figures. So you can be able to get this direct. That 8760 times 0, you open the bracket. Make sure that 0.25 power 6 is inside the bracket. You close the bracket there, times, you open another bracket, 0.75 power 14, you close the bracket, and then you put is equal to. What are you getting?
0.1686.
So you are able to arrive at this answer, and this is actually the answer that we need. So up to that moment, I want us, actually, I cannot go without doing question number 3 because it is testing another skill that you also need to understand. Lukale, give me the next.
Excuse me.
Yes, yes, please.
Before you go to the next one,
Yes, yes.
does the last decimal point matter? Because I'm getting 0.1683.
0.1683. I know you can get that
yeah.
because you
Yeah.
are using the figures that were rounded off. Sindio?
Yeah.
Did you feed this
Okay.
direct? I know
Yes.
you multiplied or you raised these powers and then you wrote them down and then you multiplied. I understand.
Yes.
If you round over, the answer is going to be slightly less than this.
Okay.
But there is no harm. Your answer is right.
Okay.
Okay. Any other question? Okay, if there is no other question, Lukale, you can give us the last question so that we can go to the next.
Okay, let me read. 25% of all students enrolled in Huduma College are taking algebra.
Okay, pause there, pause. 25% are taking
Yes.
algebra. Then proceed.
30 students are chosen at random.
That is student. That is students. Actually, we will find that our n is going to be that students.
Find the probability that
Yes.
exactly 7 students out of the 30 are taking algebra.
Our n is going to be 7. So if 25% are taking algebra, then the probability of picking an algebra student is going to be 25%, which is the same as 0.25. And therefore Q is going to be 1 minus P, which is the same as 0.75. Find the probability of picking exactly 7 students who are taking algebra. So you are asked to get P x is equals to 7. So you are going to get this. It is n factorial, which is 30 factorial over 7 factorial into 30 minus 7, close the bracket factorial, times 0.25 power x, which is 7, times q, which is 0.75 power n minus x, 30 minus 7, which is 23. So I want us to feed this information in the calculator direct, because if you do that factorial is a very big number. Let us feed it direct. We do that factorial, shift factorial, divide by, because this line simply means there is a division. You say divide by Then you put these figures on the denominator part to be in bracket. You say divide by, then open the bracket, 7 factorial, 7 shift factorial times 30 minus 7, which is 23, times 23 factorial. Then you close the bracket so that we can get the answer for the first part. So the answer for this part, what are you able to get? Yes,
2 million.
2 millions.
2,005,800.
Yes, 0.35, 800. Then we multiply. Then let us continue. Without labbing what you have on your calculator, you just put times, open another bracket, 0.25 power 7, 0.25 power 7, close the bracket, times, open another bracket, 0.75 power 23, close the bracket, then you say is equals to what? So the answer you are going to get there, it is going to be a cumulative answer for everything. I don't know whether there's anybody with a different answer, but I'm getting 0.1662 to 4 decimal places, but it is 235674. Are you able to arrive at that answer?
Yes.
Okay. And note always, anytime we are calculating probability, we said the probability cannot be an answer that is greater than 1. Always your answer should be 0 point something. If it is more than 1 or if it is negative, then that answer is automatically wrong. So that is actually the case. Lucale, understand this one had part B?
Yeah. Find the probability that fewer than 5 students out of the 30 are taking algebra.
Fewer than 5. That is x should be less than 5. If they are less than 5, it simply means that either x is equals to 0, there is none, or x is 1, or x is 2, x is 3, or x is 4. When you are told it is fewer than 5, it simply means that either there is none doing algebra, or 1 is doing algebra, or 2 are doing algebra, 3 or 4. But they should not be 5 and more. So if you find a case like this, then you should come here and you do this. Remember, our n was 30, our p was 0.25, our q was equal to 0.75. Now what you need to do is to calculate them here. So here, when x is 0, you'll find that the probability that x is going to be equal to 0, you are going to get n factorial, which is going to be 30 factorial over 0 factorial, because x is 0 for that case, into 30 minus 0, and then you multiply by p power x, which is actually 0.25 power 0, times q power 30 minus x, which is 0, which is now 30 minus 0, which will give you 30. You calculate that one, you get the answer when x is 0. If we are looking for the probability of x equals to 1, then it simply means that the probability that x will be equal to 1 will be equal to 30 factorial over x is 1 factorial into 30 minus 1 into bracket factorial times 0.25 power 1, because our x is 1. Then we multiply by q, which is actually 0.75 power 30 minus 1, which is 29. You get the answer for that part. You also come here when p is equals to 2, probability that x is equals to 2, you find that now is going to be 30 factorial over x is 2, now is going to be 2 factorial into bracket 30 minus 2, that is 30 minus x, we can simply put here directly 30 minus 2 is 28 factorial. Then you multiply by 0.25 power 2 times 0.75 power 30 minus 2, which is 28. You get the answer there. You proceed to when x is 3, so probability that x is equals to 3 is going to be 30 factorial over 3 factorial times 30 minus 3, which is actually 27 factorial. Then you multiply by 0.25 power 3 times 0.75 power 30 minus 3, which is 27. You get that. And then lastly, you go to probability when x is equals to 4 is going to be equal to 30 factorial over 4 factorial times 30 minus 4, which is 26 factorial, times 0.25 power 4, because x is 4, times 0.75 power 30 minus 4, which is 26. You get that. So you are going now to get these answers for each and every one, and then we shall add them together so that we can get that probability. It is as simple as that. So we can do it together. Let us finish it. You will find that for the first one, remember our Q here is 0.75. Let me actually write it like that. .75. So you can be pressing your calculator so that we can get those answers. 0.75 power 30. So we can get this answer direct. We do 30 factorial, shift factorial, divide by, then we put into bracket, divide by into bracket. Then we have got this part here, 0 factorial, 0 shift factorial times 30 minus 0 is 30, minus 30 shift factorial. We close the bracket. Then we multiply by, I want us to multiply everything once, times 0.25 power 0 times 0.75 power 30, so that we can get the whole of it once. I'm getting actually an answer of which you will confirm whether it is the same answer you are getting. 0. We are supposed to have 3 decimals, so it is 1, 2, 3, and then 178, 175, and then 8. Let me just put 179 for that first answer. For the second answer, we can come here and we say 30 factorial, 30 shift factorial, divide by into bracket 1 factorial times 29 factorial here, because 30 minus 1 is 29. 1 shift factorial times 29 shift factorial, close the bracket. 1 factorial times 29 factorial. Then we multiply by 0.25 power 1, which is the same as 0.25, times 0.75 power 29, so that we can get an answer of 0.00, 0.00 178. We can say power 9. So that in all cases, actually These were how many decimals were this? They were 1, 2, 3, 4, 5, 6. This one are 1, 2, 3, 4, 5. So we can say 0.1786. 1786, so that we can have the same number of decimal. Sorry, I'm just rubbing. 1786, so that we can have the same number of decimal places. Then you do the same to this, which will be equal to 30. 30 shift factorial, divide by, you open the bracket. Then we are going to have 2 factorial, 2 shift factorial times 28 factorial, close the bracket, times 0.25 raised to power 2 times 0.75 raised to power 28. I'm getting 0.00861 to 6 decimal places, so that they can all be 6 decimal places. We go to this one where we have 30 factorial, divide by, into bracket, 3 factorial times 27 factorial times 0.25 power 3 times 0.75 power 27. I'm getting 0.0268 0.26853 And then lastly, we can do that 30 factorial times, not times, but divide, sorry. Divide by, make sure it is in bracket, divide by, into bracket, 4 factorial times 26 factorial, close the bracket, times 0.25 power 4 times 0.75 power 26. You get it is going to be 0.0064042. Then, for you to get the final answer that you are supposed to have here, you just add this probability. The probability that x is equals to 0 plus the probability of this plus this plus this plus this. Then you get your answer here. I know now that one you can be able to add and get the final answer. Unless somebody has got a question. Anybody with a question anywhere? So if you are told the probability of less than, you know, in all other cases that we have handling, we have been told the probability that x is equal to this, but this one was saying x is less than a certain value. If it is less than a certain value, we need to start from 0 up to the maximum value it can go. So it cannot reach 5, but any value below 5. So it is 0, 1, 2, 3, and 4. We get the probability for each of the x's, and then we add them. Then it is going to be our solution. You have a chance to ask a question if you did not understand anywhere on the binomial before I go to the Poisson. It seems everybody is comfortable. So allow me to take you to Poisson. Poisson is normally applicable in areas like the banks, whereby you might be interested to know the number of customers who will visit the bank in a particular day. We can also apply it in areas like maybe the roads. Maybe we are interested in knowing the number of accidents that can happen in a particular time period. We can also apply it in maybe the poster, where we want to know the number of letters that are going to be delivered, things like those. So under the Poisson, we are going to have this formula being applicable. But before that, you will find that we shall be talking about things that are either arriving or happening at a certain rate. Like, for example, if a bank normally experiences an average arrival of 6 customers per 15 minutes. After every 15 minutes, an average of 6 customers have visited that particular bank. So we have got that average arrival rate, which we are going to denote by the mu. It's normally denoted by something like U, or it is denoted by something like that, which we call, this one is normally known as the mu. This one is normally called lambda. So the mean arrival can either be in terms of mu or lambda, whichever you feel is going to be applicable. So the probability that maybe we are going to have X customers in that particular bank is normally given by the formula. Let me use the lambda power X. And then we have got what we call the constant E power negative lambda over X factorial. Remember, this one can also be written as the mu. Remember, mu has got a tail here, times E power negative mu over X factorial. And I want to repeat here, when we have factorial, it simply means if, for example, we have 10 factorial, it is 10 times 9 times 8 all the way up to times 1. If we have 20 factorial, we start from 20 times 19 times 18 times 17 all the way up to times 1. Then this E, it is actually a constant that you can get in your calculators. If you can hold your calculator, just hold it so that I can show you where the E is. The E. Are you able to see where you have the button for log? Then adjacent, the next one, there is a button that is written log. Then adjacent that, there is a button that is written IN. On top of this, there is E power X that is written there. If you can be able to locate that on your scientific calculator. So this is the E that we are talking about, the E. It is also known as the Euler's constant. From the name of this is actually the person who invented that constant, so it came to be known as the Euler's constant. So this value, you just feed it from the calculator direct. You just feed it from the calculator direct. But note, remember here it is E power negative mu or power negative lambda. But remember, lambda and mu, they stand for the same thing. Only that in some books, they will find them using mu. In other books, they will use lambda. But the value for lambda, it is actually the same. If, for example, you want to get E power 2, if you want to get E power 2, what you do, you press shift. Remember, I told you that any value or any letter that is written not on the button but on the calculator itself, you normally access it by using the shift sign. So if you want to get E power 2, you just shift and then you press that IN, this button. Don't put power because the E that we have here already is power. So you just shift and then E and then you put 2. So you get that. You get it is 7 point something. If, for example, you want to get E alone, you just shift IN is equals to, you get that answer. It's actually, the value for E is approximately 1.61. Sorry, let me do it again. Shift. Are you able to get it? So you don't put the power. If, for example, it is power 2, you just shift E and then you just put 2 without the power. You just get that answer. If it is E power 3, it is going to be just shift, then you press E, then you put power 3. You put 3, not power, E3, and then you get that answer. Already, this E is raised to power X. So the X, it is now the number that you are putting. When you put E3, then it is simply E power 3. So if, for example, it was -1, you just shift, then E, and then you put -1, you just get the answer for that direct. So the lambda, it is the mean arrival rate, which is the same as mu, and then X, it is the number of actually customers that you are interested to know, the probability of them appearing, and all that. Is actually a very short formula, and which we can be able to apply. I want us to start by this question that I'm going to give, but I know it is in your notes, which reads that, let me just clear my board first. Okay, we can have this question that if you have it, I know it is in your notes. If the electricity failure occur according to Poisson, the electricity failure occurs according to Poisson at an average of 3 failures. You are told that it occurs at 3 failures every 20 weeks. We normally experience electricity failure 3 times every 20 weeks. Now you are told, calculate the probability that there will not be more than 1 failure. There will not be more than 1 failure. We are not going to have more than 1 failure during a particular week. I don't want to start with that question. I want us to start with a very direct question, then we come to this. Lucale, are you there? Lucale?
Yes, I'm there.
Just can you go to the Poisson question? Poisson
Yeah.
questions, and let us have the first one, and then we come to this. I want us the so direct question.
A small business receives on average 12 customers per day.
Just a minute. 12 customers a day.
What is the probability that the business will receive exactly 8 customers in 1 day?
Okay. Whenever you are tackling this question on Poisson, you need to see, you see here, the question is talking about per day. The average that you are given of 12 customers is for 1 day. Then you need to look at the question that you have been asked, whether it is also reading per day. If it is not per day, then we need to work out something here. But the good thing, we are told that 12 customers normally arrive per day. And now we are asked the probability that, just repeat it, Lucale.
What is the probability that the business will receive exactly 8 customers in 1 day?
Probability that X is going to be equal to 8. So because this question is also per day, then this figure is going to be our lambda or mu direct, because it is per day here, and here we are asked per day. So our lambda is going to be 12. Our x, it is 8. So we can come here now and we get that particular probability, and we say that probability that x is going to be equal to 8 will be equal to, we know it is supposed to be actually lambda power x. Then we multiply by the Euler's constant, power negative lambda, and then we multiply or we divide by the x factorial. In this case, our lambda is 12. So we shall come here and we do 12 power x. Our x is 8 times the Euler's constant, which is e power negative lambda, which is now negative 12. Because lambda is 12, then we raise it power negative 12, and then we do over x factorial. X factorial is going to be 8 factorial here. So if you work out this, what are you going to get? If we work out that, what are we going to get? That is a question. So we are going to do it like this. 12 power 8. 12 power 8 is equals to, actually it's coming to a very big number, 429, 981, 696 times, what is the Euler's constant? E power negative 12. You just shift E, and then you just put negative 12. Don't put power. You are going to get what? Let me go to the new page. I start with the 12 power 8 so that I can have a big space. Is going to be 429. Sorry. Four 29, 981, 696. That is 12 power 8. Then we multiply by the Euler's power negative 12, which is the same as shift E power, and then you put negative 12 without power. It is giving us a power negative 0.6. So we need to put 5 zeros, 0.00000. Then we put 614. 6144. Let us stop there. And then we divide by x factorial, which is the same as 8 factorial. 8 factorial is the same as what? 8 shift factorial. 4320. Can we work out that now so that we can get now the probability that x is going to be equal to 8? Multiply that, and then you divide with 4320 so that we can get the answer to that question.
Is 0.066.
You're muted. We can't hear you.
I'm saying actually the answer is 0.066 or 0.655. If you have it this way or this way, it is correct. Part B of the question, Lukale.
It does not have part B.
It does not have part B.
Question 2.
Okay.
Yeah.
Okay. Give me question 2. Yeah, give me question 2. This one now, and then we go to the question that we left.
A student receives on average 7 text messages in 2-hour period.
Okay, just a pause there. 7 texts. 7 texts in 2 hours.
What is the probability that the student will receive exactly 9 messages in a 2-hour period?
What is the probability that is going to receive X 9 in?
Yeah.
In how many hours?
In a 2-hour period.
In 2 hours period. This one is also direct because here it is talking about in 2 hours. This one is also talking about in 2 hours. So to calculate that, you just go and apply the formula direct. And you say here, our lambda is actually the mean number of texts, which is 7. And then our X is 9. And what else do we need? We don't need anything else. So the probability that X is going to be equal to 9 would be equal to lambda, which is 7, power X, which is 8, then the Euler's power negative lambda over X factorial, which is now going to be 9 factorial. Sorry, this power is power, this power here is power 9. It is power 9 because X is power 9. So you can get that direct. There's no even need of just having those too many numbers. You can have 7 power 9, 7 raised to power 9 times shift E negative 7. You get a certain figure, then you divide by 9 factorial. You divide by 9 factorial. If you do that, what do you get? If you do this, 7 factorial. Yes? I'm getting 0.10140, 404. Anybody who is getting an answer that is similar to this? Hello, are you getting the same answer?
Yes.
Okay, so that is the key thing about Poisson is to look at what you have been given. If you are given a certain rate, maybe per hour or per day, just go to the question, find out whether they are also reading the same. Okay, this question has got part B, sorry, Lukale.
Part B says exactly 24 text messages in an 8-hour period.
24 texts in 8 hours.
Yeah.
8 hours period. Now this is the case that I was talking about. The other one was talking about the 2 hours. The other was actually the question. It was reading the text messages were being received in 2 hours period, but now the question is talking about 8 hours period. You need now lambda. You cannot use 7 as the lambda in this case. You need to work out. You need to work it out, and you can say if 7 were being received in 2 hours, what about the number of messages that you are supposed to receive in 8 hours, if that is the rate that you are going to use? Or I can come here and put it in other way, but it is the same. I can come here and say this. We can say this, that in 2 hours, we were receiving 7 texts. In 8 hours, we are supposed to receive how many texts? So it's going to be 8 hours, I cross multiply, 8 hours times 7 texts over 2 hours. So you find hours and hours will cancel by 2, 1, by 2, 4. So it's going to be 4 times 7, which is actually 28 texts. This is 28 texts. This is now going to be your lambda. So you need to be very careful on the question, whether they are reading the same thing. If they are not reading the same, then you need to work out on the lambda. So the lambda that we are supposed to use here, it is 28, because 7 was for 2 hours. Then for 8 hours, it is supposed to be 28. Then you can come here and say the probability. Question was asking what to carry probability of receiving. Lucale?
Receiving exactly 24 texts.
Okay, of receiving X to be 24, of receiving 24 texts. So our X is 24. You will find it's going to be the formula. We just repeat it, the lambda power X, which is now 28 power 24 times E power negative 28. And then we divide by the X factorial, which is 24 factorial. You get that answer. So that is actually very important part that you need to understand in Poisson. Read the mean, whether the mean and the question that is being asked, they are actually talking about the same interval. Then this one, you just feed in the calculator direct, because I know 28 power 24 is actually a very big number. 28 power 24 times E, which is shift E negative 28, you can say is equals at that point, and then you divide by 24 factorial. The answer divided by 24 factorial, which gives you 0.060095, something like that. It will give you something like that. At that point, I can go to the question that I was a bit to start with. I was almost starting with. Now that I have covered this part, so that it can form our second emphasis on the same, whereby you are told if electricity failure occur according to Poisson distribution with average of 3 failures every 20 weeks. Electricity fails 3 times, approximately 3 times after every 20 weeks. Calculate the probability that there will be no more than 1 failure in a particular week. Probability of no more than 1 failure in a week, in a particular week. So this is actually a question that is testing 2 concepts. Number 1, this failure was for 20 weeks. But now the question is talking about in a week, which is the same as per week here. So we need to change this mean to be per week for 1 week. So we can say here, if in 20 weeks we experience 3 failures, what about in 1 week? How many failures do we expect to experience? So it's going to be 1 week times 3 over 20 weeks. So you'll find that this is the same as 3 over 20 per week. So the chances of having a failure in electricity in 1 week is supposed to be this. We cannot use 3 because 3 is for 20 weeks and the question is talking about in a week. So we need to have an average that is talking about per week. So it is 3 over 20. Now, having understood that, there is this part that is saying no more than one. No more than one. No more than one, it simply means that either we have 0 failure or 1 failure, but not more than 1 failure. No more than one, that is actually what it means. Either there is no failure at all or only one, but not anything above 1. So what we need to do, we need to come here and do some calculation. So no more than 1 is the same as the probability of x is equals to 0 and the probability that x is going to be equal to 1. So probability of x is going to be equal to 0, we are going to have it as this. It is going to be given by the lambda power 0, because x is 0, times e power negative lambda, and then x factorial, which will actually be the same as what? Lambda, we have calculated it to be 3 over 20 power 0 times e power negative 3 over 20, then over 0 factorial. We get that answer. Then we also calculate the probability of x is going to be 1, which will be equal to what? Lambda, it is 3 over 20 power x, our x is 1, times e power negative 3 over 20 over x factorial, which is 1 factorial. We get the answer for that. And then we shall add these two answers to get that probability. Then we shall add the two answers to get this probability. So let me assist you to get this answer, and then now I can leave you work out the others. We can end the class at that point now. Any number raised to power 0 is 1. That is the rule. So if we do 3 power 20 power 0 is going to be 1. Then let us concentrate on this part. So we are going to have actually 1, but you can confirm that 1 times shift E, and then we put power actually negative 3 over 20 over 20 without putting the power. I'm actually getting 0.8607, and then you divide by 0 factorial, which is actually 1. 0 factorial is 1, so the answer is going to be 0.8607. You come here, you do 3 over 20 power 1, which is the same as 3 over 20, times e power negative 3 over 20, which is the same as 0.129,106. 1 factorial is the same as 1 also. Kwa hivyo itabaki kuwa 0.1291. Then you add the 2. Then you add the 2 so that you can get the answer. If you add the 2, my answer tells me it's supposed to be 0.98981, something close to that. So that is how you calculate the Poisson. That is how you calculate the Poisson. But the point to remember, the mean arrival or the mean of the things happening, they should be the same as the question is asking. If they are not the same, then you have a responsibility of recomputing the lambda so that you can have now a correct figure to apply. Having said that, I want to end the class at that point, but I cannot do so before you ask me some questions or some clarifications.
I was just wondering,
Yes.
all those questions that we've been doing from the start, they're just asking about probability. So at what point do you decide which formula to use?
Okay, that is a very good question, Macrin. That is a very good question. Let me give you a summary of that. When we did the normal distribution, in the question, you must be given the mean and standard deviation. If you find the question has given you the mean and standard deviation, then you use the normal, where you are supposed to calculate the z value, which is actually x minus the mean over x minus the mean minus divided by the standard deviation. So anywhere you will find a question talking about the standard deviation, then it is a normal distribution. And you need to calculate the z-score and then use this z-score to find that mean or find that probability from the z table or the normal table. That is actually number one. Number two, if you go to the binomial, and now the other one is Poisson, you might wonder which one is which. In the Poisson, you will be given the average rate of occurrence. The average rate of occurrence, you can be told the average rate of electricity failure, the average rate of customers arriving, the average rate of all this. You will be given that. Anytime you have got the average rate of things happening, then it is actually supposed to be the Poisson, and you apply the Poisson formula. But if it is giving you whereby a case whereby you are given the probability of success of an event, and then now you also have the failure, then you go to the binomial. So actually what can confuse you is these two. For the normal distribution, it is automatic. You will be given the mean and the standard deviation. And these two, there is nowhere you will be given the standard deviation. But in this Poisson, you will be given the average rate of things happening. Now you apply the formula. But this one, you will be told in maybe in an exam, the probability of people passing is this. You will not be given maybe something like an average. That is actually the key distinguishing factors. And hence, you can be able to tackle them. Macrin, I don't know whether I have answered your question.
Yes.
Yes. So you need to note that. You need to note that. Standard deviation, just it is normal. But this one, if you are told the average, maybe the number of cars passing a particular road is this, just go to the Poisson. But the other one, you will be given the number of successes that you need to calculate and the total number of experiments that is being done. You use the binomial.
Okay, thank you.
So, having said that, I think it is the high time we end the class. But if you have any question, just reach me out or ask here, and then I can be able to clarify for you. If maybe you find that it is a bit challenging to ask here, just feel free, especially on the weekends. You can engage me, I can show you something. We can have a Zoom class for two of us if we are only two. And I explain to you some things that maybe you find to be a bit hard for you to understand. If there's no question, please let us end the class at that point. And I thank you for coming on board. As I wish you a lovely night and a blessed week.
You too. Thank you.
You too.
Okay, karibu.